So your second test was due yesterday. I'll start grading it soon. And I will be at my office hour Wednesday and Friday, but Thursday is Veterans Day, so we aren't going to have a Zoom meeting. Okay, and then today we're doing notes for your next homework, which is homework number 9. It's about graphing inequalities with 2 variables. All right, so we're looking at linear inequalities in 2 variables. Okay, it'll have form of, what's the form? Of, say, ax plus by less than c. A, b, and c are numbers. X and y are your variables. And we can't have both a and b be 0. You could have a be 0 or b be 0, but not both at the same time. Okay, and I'll be right back. Okay, thank you. And let's see. The other part of this is to be able to replace this sign with the greater than, or you can have less than or equal to, or greater than or equal to. So Okay, the only way to find the solution set for an inequality with two variables is by graphing and shading the solution section. So you're going to have one number line for one variable, the other number line for the second variable. And then part of the XY plane will be shaded in to represent our solutions. Okay. Okay, I broke it down into some steps. First thing you need to do is to temporarily replace your symbol, your inequality symbol, with an equal sign and graph the line. But that's only to get started with the problem. So don't completely forget that symbol. Just start with replacing it with an equal sign. And there's two things you want to do before you just draw the line. So you put an equal sign in place of your inequality sign. And then before you draw the line that's left over, you want to check the symbol. If it was a strict inequality, draw a dotted line. If it has an equals in there, less than or equal to, greater than or equal to, it's going to be solid. Okay, so this is like number 1, part A. If it's one of these symbols, so it's like a dashed line or dotted line. So just kind of represent that it's not actually included in the set, it's just a boundary. Okay, if there was an equal sign, then you do include that part as part of the solution set. So draw a solid line to represent that we are including those values. Part B. If the sign is one of these ones, draw a solid. Okay, I'll be right back. I have a grumpy cat that I'm trying to distract. Okay, let's see. There's just a little bit more to this. After we have our boundary, it's either dots or solid, you need to pick a test point. Be sure that you do not test a point that is on the line. You need to pick any point away from the line. So number 2 is to test a point. Be sure that the point is not on the line. And then there's 2 parts to this. If your test point comes out true, it is a solution and it is on the solution side of the boundary. And you shade that side. We'll put it up in just a sec. If it's false, it's not a solution. You want to go on the other side of the line and shade that side. So part number 2, first part, if true. Your point is a solution. And you want to shade over that point and all of the points on that side of the line. Which, by the way, you can test other points and find out that they're solutions or not. But you really need just one. And if it's a solution, you shade on that same side of the line as the test point. Okay. If you put in your point and you have a false statement, it's not a solution. And you don't want to shade over that point. You want to go on the other side of the line and shade on that side. So shade on the opposite side of the line. Okay, and that should be all there is to that. Now we just need to practice. Okay. Let's do kind of an easy one. We will graph. Let's do y greater than x minus 1. So you've got two variables, x and y. The horizontal line be our x values. This is going to be for y. Right back. Yes. All right. Thanks for being patient. So the first thing to do is to take that and replace the symbol with an equal sign. But since it's a strict inequality, I want to do this with dots. So when I put this on my graph, it's going to be dashed or dotted. Okay, this line starts at a y-intercept of -1. So 0, -1. And then it has a slope of 1, or 1/1. So I'm going to go up 1, right 1. Up and over, up and over. So one more time. And then I'm going to connect these with just a few dashes or dots to represent the boundary. Okay, so split the plane into two parts, above the line and below the line. And then I pick a test point. Any point, as long as it's not on the dotted line. So the origin is nice, it's away from the line, or I can go even further away. Let's go to like -2, 0, way over here with that point. That's my test. And now you want to, once you've got the boundary down, you want to go back to the original symbol that you had, the y greater than x minus 1. Okay, it's in this part that we're going to test to -2, 0. This is my value of x. This is y. Is 0 greater than -2 minus 1. 0 greater than -3. It's true. So that is a solution, and that test point is on the solution side. So I'm going to shade over that side. And you want to come up very close to the boundary, but you can't cross it or include it. So just sketch as best as you can up next to that dotted line. And this is a solution. This is the solution section. Okay, next one. Move on to graph. Y less than or equal to 2x plus 1. So two variables, x and y. Then to get started, I replace this with an equal sign, and it's also going to be solid when I actually put the line down. Okay, so I want to draw y equals 2x plus 1 as a solid line. So we'd go to 0, 1, for y-intercept of 1. And this time my slope is 2. So I want to go up 2 and to the right 1. Up 2 over 1. So again, up 2 over 1. This time it's a solid line, straight through. And I say, as soon as you get your line solid or dotted, just erase that part so that you don't get confused. You want to go back to the original symbol. That symbol. Okay, and in this inequality, we want to test a point. Any point that's not on the line. A good point is usually the origin, but I want to make sure that I know my test point is far away from the line. So I'm going to pick +3, 0. So test that spot right there. So again, back to that original sign, and your value y is going to be 0. Is that less than or equal to 2 times 3 plus 1? 0 less than or equal to 6 plus 1. Yes. 0 is less than or equal to 7. So it turns out that I do want to shade on that side of the line. Again, I did find a solution, and it's on the side of like the full solution section. And this time you can go up to the solid line because you can include these values, just not past. I'm going to go from the line and all the way over on this side down. And the line would keep going in both directions that way, and you'd keep shading all the way below the line. Another one where we graph. y plus 1/2 x greater than 3. We have our x and y. And when I draw a line, I want it to be with dots. So like just for a quick second, we put an equal sign down and maybe on the other board. We graph. Y plus 1/2 x equal to 3. With dots. I would subtract the 1/2 x from each side. That way I've got y equal to negative 1/2 x plus 3. And I would start at an intercept, a y-intercept of 3, or at 0, 3. And then use your slope. Okay. Let's try this one. Space out this. We're going to go to 0, 3. And with the slope of negative 1/2, I want to go down 1 and to the right 2. Down and let's do that again. Down 1, right 2. Do one more time. So like then it'd be down 1 more and over 2. And then the line through this is going to be dotted or dashed. Okay. Now we can pick a test point, and we don't want to go on use any of this anymore. You want to use your test point in this statement here. Let's test the origin. So 0, 0 is a nice point to test. And I can definitely tell it's not on my line. It's way over here. Okay. 0 for y and 0 for x. So 0 plus 1/2 times 0. Is that greater than 3? Zero plus 0 greater than 3 would be 0 greater than 3, which is false. So that is not a solution, and this is not the solution section. You want to go to your boundary and shade above, or shade on the opposite side of that point. That would be the solution section. Y greater than 2. So we are going to have a y-axis and an x-axis. Then we're going to put an equal sign here, but also when we draw the line, it's going to be with dots. So we'll have y equal to 2. Okay, so this line has no x value, so x can be any number. X can be positive or negative, but y has to be equal to 2. So I have to go with points that look like 0, 2, or you can have 5, 2, or negative 10, 2. Just as long as y is always equal to 2. And x is any other number. Oh, and then they're supposed to be with dots. Okay, and then you need to test a point back in the original statement. So pick a point not on the line. I'm going to pick a point like we're going to go with positive 1, negative 2. We're going to go over here and test this point. Okay, that's my x value. That's my y. But all I need is the y value. So we're just going to pick this part of the point and put it into the inequality. See what happens. You get a negative 2. Is that greater than 2? Nope, that'd be false. So we do not shade over this point. You want to go to the boundary and shade on the opposite side above that dotted line. You can, sketch it in however you like. I'm just going to kind of do it at an angle. Luckily in your homework, it just kind of fills it in for you because it's online homework. Okay, that's the solution section. Okay. And then one more of these, and then we have a system of inequalities. So you just do the same process, and then you repeat that process, and then the overlapping section will be the solution set. We'll write it down after one more example. We're going to look at x less than or equal to 3. X and Y. And we're going to have a solid line when we draw X equal to 3. Okay. When there's no Y value, Y can be any number. So Y can go up towards positive infinity or down to negative infinity, but X has to be 3 for all of the points in the graph. You go over 3 for X, and then Y can be any number. And just luckily I was able to draw a solid line. That's my boundary. And then pick a test point. I do think the origin is a good point, but just to be clear, I'm going to pick something like, we'll go with -2, +3. So if I test that point, -2 is the X value, 3 is my Y value, and I only need the number for X. I only need this part of the point. Okay, so back to the beginning, we're putting in -2, and is that less than or equal to 3? Yes, it is. That's true. So I do want to shade over this point, and then all points on that side of the line are solutions as well. So you can come up to the line and include the line, just don't go past. Okay, so now what we do is put a few of these together, which is called a system of inequalities in 2 variables. Or we'll just call it a system of inequalities. So these are going to be steps. The first step is to go through that process for the first inequality. We want to graph and shade the first inequality in the set. Okay, next. Graph and shade the inequality after that, and just keep going till you've gotten all inequalities, gotten the solutions for all of the inequalities in a system. So this is just something that someone pointed out to me to stay more organized is just to go through each inequality and fully do like the solutions for each one at a time. So do the first one, do the next one, and then keep on going until you've shaded all solutions of the other inequalities. Okay, and then at the end of all of that, there should be an overlapping part where the solutions kind of shade over each other. And you maybe want to extra shade that part, and that's the solution section. So the overlapping section is the solution section, and you might want to highlight that piece. Cool. So we just want to practice this for the rest of class, and that should be enough to help you with the homework. So the first few systems, there's just 2 lines, but we're going to try one that has 3 lines if there's time. Okay, and then in my classes, the systems were always paired together with a huge bracket on the side, but I think maybe it's just the style or something of the book that they don't include the bracket. They just put the lines or inequalities kind of listed. Like this, y less than 2x plus 4. And the next is y greater than or equal to negative x plus 1. So in the past, my teacher would put a big bracket on this side to just show that this is a system, but just to get used to the homework, we're going to leave it like that. And just take the first one and find its solution section. X values, y values. And I'm going to momentarily put an equal sign here, but make sure it's a dotted line when I draw the line. Y equal to 2x plus 4. So we're going to have an intercept of 0, 4. And then your slope of 2 would be up 2 and to the right 1, up 2 over 1. And you can go again up 2 to the right 1 from that spot. And connect these with dots. Well, it's a pretty good sketch, but you want it to be more of a straight line. Okay, we're going to stick with this, go back to the original statement, and test a point. Let's go ahead and test the origin, which is here, 0, 0. Okay, we're looking at 0 less than 2 times 0 plus 4. Is 0 less than, that'd be 0 plus 4, which is 4. Yes, it is true. And I want to shade over the origin and on that side of the boundary line. And that's only part of the problem. You have to do all the same work for the next part. So we've gotten to y greater than or equal to negative x plus 1. So I want a solid line for this. And I'm going to put y equal to negative x plus 1 and then draw that line. Okay, we're going to 0, 1 as the y-intercept, and the slope of negative 1 means you want to go, maybe look at this as negative 1 over 1. So down 1 and to the right 1. Zero, 1. It's down and then over to the right. And then down and over. Maybe one more. Down and over. And then connect those with the solid line. Okay. After that, for the blue line, for this line, we want to test a point. I could test the origin again. It's not on the line, but it is kind of close to the line. So if I want to pick some other point, it's fine. Let's just use the origin. Just be careful to not always test the origin. It's only if that's not on the line. You have to pick a test point that's not on your boundary line. Okay, once you've got your line down, you don't want to use this symbol anymore. You want to go back to the original inequality, y greater than or equal to negative x plus 1. So put in those values. You have a 0 greater than or equal to negative 0 plus 1. Negative 0 is 0. 0 plus 1 is 1. So this is saying is 0 greater than or equal to 1. Which would be false. So I don't want to shade over the origin. I want to go to the blue line and shade on the opposite side. So we're going to shade this way. And the part that's it's called like cross-hatched, or where it overlaps this shading and that shading, that's the solution section. Usually you find a way to maybe extra shade it or highlight it. So I'm just gonna do this way too. So that's the solution section, this little piece right here. Next one. The first inequality is y less than 2x plus 3. The other one is y greater than 2x minus 1. So the best way to keep things organized, I think, is to do all of the work for the first inequality, and then we'll do all of the work for the next inequality and highlight the overlapping part at the end. So let's get a dotted line. That part means dots. And we'll put an equal sign right here. So y equal to 2x plus 3. So we're going to 0, 3, and then the slope of 2 means we'll go up 2 and over 1 to the right. 0, 3. Up 2 over 1. Up 2 over 1. And then dots. And we can test the origin. It's not on your line. It's over here, 0, 0. Once you've got the line, you really don't want to look at this symbol anymore. I'm going to go back to the original sign, the less than sign. Okay, 0 for x and 0 for y. So 0 less than 2 times 0 plus 3. 0 less than 0 plus 3 is 0 less than 3. Yes, that's true. So I want to shade over that point and on that side of the dotted line. So that's all done. We can move on to the next line and do all of the work for this inequality. It's also going to be drawn with dots. Strict inequality in there. And just for a moment, we're going to put y equal to 2x minus 1. So it's an intercept of 0, negative 1, and a slope of 2 over 1, which means it's the same slope. So I'm going to do my best to draw these as parallel lines since they have the same slope. Starting at 0, negative 1. Go up 2 over 1, up 2 over 1, just like this slope. So I'm going to actually just kind of draw my dotted line to be parallel to that line. Okay. I'm going to use some color. So if you can see this, this is supposed to be blue, so that I can kind of hopefully point out what we're testing. Okay, let's test a point for this line. It's really close to the origin. It's not going through the origin, but still, I'm just going to pick a point that's far away from that line. We're going to go to negative 5, 0, right there. Okay. I've got 0 for y. Now have 2 times -5. So guys, 0 greater than -11. Which is true. 0 is greater than a negative number. So from this dashed line, you want to shade over that test point. We're going to do this. Okay, so the part where the solutions overlap is the solution section. So we're going to extra highlight this part and label it. You can't see. It's a good enough. You get it. Okay, next one is going to have, let's say the system is x less than 4 and y greater than -1. Let's put x less than or equal to 4 and y greater than -1. I think this will be the last one for us today. So start with that first inequality, x less than or equal to 4. So it's going to be a solid line. And we're going to put x equal to 4, which is where y can be any value it wants, but x has to go over to 4 for all of this. Okay, I have that line. Then I test a point, which let's go ahead and test the origin. But all you need is the x value from the origin. Okay, so really all I need is this part, the 0 from the x position, or from the x coordinate. So we're putting that 0 in right there. Is it less than or equal to 4? Yes. So for this line, I tested that point and it is a solution. And over here, we've got solutions. That part's done. Next we do y greater than -1. For the strict inequality, it's going to be dots. And we're looking at a dotted line for y equal to -1. So x can be any number, left or right, but y has to be at -1 for all of the points in its graph. Down to -1, over, and it's dashed. And then for this line, we'll go ahead and test the origin again, 0, 0. I'm putting it into the inequality y greater than -1. So from the test point, I'm just taking the piece that has like the y value, that part right there. Put that in for y is 0 greater than -1. Yes. So for the dotted line, I want to shade up over that test point. Let's just go straight. And then the overlapping part is the solution section. So I might extra highlight this way. And then that way. So this piece over here. I think we're pretty much out of time. Yep. So that's it for today. And I hope this helps with your homework. We do not meet on Thursday, but I will be at office hour